Good morning, sixth graders. I just wanted to make a little instructional video to help you get started on this assignment for today. Okay, so today we are going to be making Bohr models of atoms, okay, pulling their subatomic particles into the correct locations. And if you don't know what I'm talking about, go back and do yesterday's assignment, okay, because that lab walked us through all of this. Okay, so it says here, drag the subatomic particles to their correct locations on the Bohr model. Then, once you have labeled the Bohr model, fill out the corresponding square using your periodic table to indicate the atom you have drawn. All right, so I'm going to do this slide number 2 with you. It's a demonstration slide. All right, so I can pick any element from the periodic table. Okay, so let's say I pick nitrogen. Okay, nitrogen is number 7. It has 14, or the atomic mass is 14.01. Okay, so if we go back here, we could write down nitrogen. Oh, and I can make it just say nitrogen. The atomic number of nitrogen is 7. The element symbol for nitrogen is N. And the atomic mass for nitrogen is, let me look back here again, 1401. Okay, 1401. We can just round it, actually. We'll just put 14. Okay, so if we know that the atomic number is 7, we also know that there are 7 protons in the nucleus, right? So we are just going to pull these protons, 7 of them, into the nucleus. You don't even have to copy them. Google Slides just gives you this unlimited amount of protons to pull on over to the nucleus. So there's 3, 4, 5, 6, and 7. Okay. Now we need to put our neutrons in the center. Well, if the atomic mass is 14, remember, in order to get the number of neutrons, you take the atomic mass and you subtract the number of protons. Okay, well, we learned that the atomic number and protons are always the same. And so 14 minus 7 is 7. So we are going to pull 7 of these guys in here. We also discussed that electrons and protons are always the same, right? So we are then going to, after I'm done here, we are going to arrange the electrons in these energy shells around the outside, just like we did in yesterday's assignment, or what we saw in yesterday's assignment. 1, 2, 3, 4, 5, 6, and one more. We'll make that all nice and full. Okay, recall yesterday that the first energy shell can only house 2 electrons, okay? So we'll put 2 in here, and we like to organize them in a way that is the same every time for easy counting. Okay, so the first one, I put 1 on the top and 1 on the bottom. Now, you could put them 2 right next to each other, but let's get in the habit of arranging them in a orderly way. Okay, so the first one, if there's only 1, you would put it up here. If there's 2, you put 1 up here and 1 down here. Okay, we're trying to get to 7, right? So that means we would need 1, and I just kind of go around the circle, 2, 3, 4. Okay, so now we've got 1, 2, 3, 4, 5, 6. We need 1 more. And so I would put this right back up here next to this one. Okay, and then this one is done. All right, remember that the first energy shell can only have 2, and these next energy shells can hold 8. All right, so you just have to arrange them, filling them up, starting in the middle. So you always have to make sure that there's 2 here before you go to the next level. Okay, well, let's say the atomic number was 16. All right, so we would put 2 here, 1, 2. We could put 8 right here on the second shell to make it full. So that would be 8, 9, 10. And we need 6 more. So we would go 1, 2, 3, 4, wait, no. 1, 2, 3, 4, 5, and 6 to get a total of 16. All right, so I'd like for you today to go in and give maybe 6 more of these. Okay, see there's a whole bunch of them right here. Try at least 6 of them. All right, and then we will see where you're at tomorrow. You don't need to turn it in yet. Okay, just hold on to it so that we can go over it in Zoom and make sure you are on the right track. Alrighty, I'll talk to you soon.